Just back from the letterbox, and what a surprise. An armful of magazines, all arrived at once. Let's have a look. They're the Microwave Journal. I think I filled a form online some time ago. I certainly didn't pay anything. Anyway, let's have a look. The September, October, November and December 2021 issues. We'll start off with September 2021. Nice and easy to open. Oh, there's two things. What is this? Almost as big as the magazine. There's a military and aerospace catalogue. Apparently a special supplement. Or is it a catalogue? Anyway, we'll look at that later. On to the main journal first. It's quite substantial. 122 pages. And there's a graph in the advertisements, obviously appealing to a technical audience. Analog devices, very well respected in all this sort of stuff. Now, first of all, is there an index or a table of contents? Well, first of all, there's the advertisements with some familiar names like Mini Circuits down there, the maker of the famous SBL1 used in a lot of radio circuits. Some more adverts. They are all microwave gigahertz stuff, as the journal says, and a big emphasis on the defense industry. More ads. Connected vehicles, 6G. EMC challenges in electric vehicle supply equipment. Modern flat panel antenna technology. Linear amplifier. And they certainly don't cram their index pages on. A lot of white space here. And there's also Microwave Journal online, so you can visit mwjournal.com. And as you might be able to see, they're also on Twitter, LinkedIn and Facebook. Well, here we are. Here's a circuit that even I can understand. A coil and a capacitor. Separates AC and DC. Actually could be useful. For instance, if you're feeding DC up an antenna line, like let's say that you had a masthead amplifier and you want to power it, but you don't want extra cable, then this circuit, plus a few extra bits and pieces, might be just what you need. Something at the top and something at the bottom. Anyway, these things operate from 10 megahertz to 40 gigahertz. They don't ignore the HF. In fact, this goes to 0.05 megahertz up to 43.5 gigahertz. So if you wanted to save a bit of time and trouble, instead of building stuff from discrete parts, well, and even the output power up to 0.5 of a watt, that would be more than enough for some small QRP stuff. I don't know if people use Whisper much on the gigahertz bands, but yep, if you wanted to build a DC to daylight whisper transmitter, then one of these amplifiers I think could be quite handy. All these conferences and things. Wonder how many have had to be cancelled. Now, up to page 22, and we are into the first article. Enhancing positioning, safety and security for connected vehicles. Yep, okay, this talks about ultra-wideband RF wireless technology. And goes on. A bit more. Yep, if you're going to have these network cars and all that sort of stuff, yeah, you need the communication system to go with them. Yeah, vehicle merging. Yeah, this is quite a long article. A Waveguide active frequency multiplier. I'm probably reading the advertisements more than the articles, but anyway, this gives you an idea of what you can get up to over 100 gigahertz. So yeah, you can multiply your frequencies. Alright, there's a personal profile, marquee microwave. Here we are, here's a, can you tell me what is new in RF today? And the answer comes back, actually very little is new in RF anymore. Almost everything that we see today is a variation of a very old and well understood theme. More RF amplifiers. Oh, high performance notch and band pass filters. Yep, well you need that with your broadband amplifiers. And more amplifiers. Leave the amplifier design to us and focus on your end system. "2021 will be a boon year for 5G and edge network markets." Well, this is actually September 2021, so most of that year's already been. Must be an old article. Now, not just gigahertz, but terahertz. From 26 gigahertz to 1.5 terahertz. I don't think we've actually got any amateur bands up there, but anyway, these are things called Vna Extenders. So they will extend your vector network analyzer. I wouldn't put one of these on a nano VNA. You'd need, this is really high performance stuff. 6G, okay. Alright, so there's a timeline there. They reckon that it's all going to start. Rollout target 2030 for 6G, so about 8 years off. EMC challenges. RF switches. So we have covered, you know, this, a lot of this is very modular. Amplifiers, bandpass filters, RF switches. Measuring EMC compliance. So this is talks all about, you know, I suppose very standard for setting up an EMC lab for testing. Flat panel antennas. Okay, broadband satellite systems in low Earth orbit. Okay, so that's like the a lot of amateur satellites at low Earth orbit. Commercial guys look like they're doing it as well. beam-forming antenna systems can actively position their main beams and their nulls at specific angular locations using either analog phase shifters or digital coding algorithms. These beam steering techniques increase the throughput of the phased array without increasing transmit power. So yeah, certainly has applications. Anyway, that's September. Let's look at October. Oh, almost forgot this little supplement. One transceiver, endless radio applications. Software defined radio, that's where all they're in. $43.5 gig real-time spectrum analyzer, doubles as vector signal analyzer. SDRs with storage for spectrum monitoring, recording and playback. Now that would be very useful. Recording whole slabs of spectrum, not just a single transmission on it. Now if you want a great software-defined radio and have an unlimited budget, then something like this is probably what you want. DC to 6 GHz or even 18 GHz. Now, this would be quite handy if you're building your own transceiver over a wide frequency range. Reconfigurable filter using MEMS switches. Developed for land, air, sea and seaborne military radios. Filter covers the primary military VHF and UHF bands from 225 to 512 and can be scaled to operate in the HF band. Configured as a 4-pole bandpass filter, this reconfigurable filter bank uses 4 MM5130 SP4T switches integrated with discrete high-power handling inductors and capacitors. The design handles up to 30 watts CW power and achieves insertion loss below 1.5 dB, which is up to 3 dB less than traditional switch filter banks. So yeah, if you're building a, say a 10 or 15 watt, it's 20 watt transmitter, then you could have these as bandpass filters. Anyway, apparently it gives you some space saving compared with using pin diodes. It has several advantages over solid state technology: lower loss, higher input power handling, better RF linearity, very low on resistance, which means low. So that's MEMS switches. Might want to look that up. Now we'll look at October 2021 Microwave Journal. Go a bit quicker this time. What are the contents? Off-chip passive components, power dividers, a steering antenna for long-reach microwave X-Hall links. Now, that could be very handy for, imagine having that sort of setup for microwaves and stuff without having to adjust tripods and dishes manually. Now here we are, now down into the component level, the sort of inductance of tantalum capacitors. Yep, you need to consider the inductance, because you don't have perfect capacitors or perfect inductors. Inductors have a little bit of capacitance, and capacitors have a bit of inductance, and it becomes more and more important when you're designing microwave stuff. Well, they would be quite handy. Whole list of them. Oh, here's what we were talking about before, steering antenna. So talk about parabolics and steering it to a particular way, but the challenge is making it steerable. It's called an electromechanical beam steering. Let's have a look at November 2021. The world's smallest high-frequency wire-wound chip inductor. Yep, that's a bit of a challenge, making inductors small. Anyway, apparently it's as small as a full stop. Measuring just 0.47 by 0.28 millimeters and 0.35 high. It operates higher Q, and higher Q minimises insertion loss in antenna matching circuits. So you can go up to, from 0.45 up to 24 nanohenry. Forget the nano Vna, this is what the pros use. By 2025, 7.2 billion antennas will be shipped for Internet of Things devices. Yep, they reckon everything will have a radio in them. Now, wideband antennas from 698 to 10,500 megahertz, tuned purely through the matching network. This shifts the focus of antenna integration from the antenna component itself to the comparatively simpler matching network, which can significantly reduce complexity, antenna selection, and integration time for IoT devices. Well, these people obviously think that you don't need a resonant antenna to work, unlike some hams. RF coaxial relays. More antennas. Understanding common trace antenna designs. Monopole, dipole, slot, patch and printed inverted F. So you've got the real basics here. And more on impedance matching. Yeah, I should read this article in a bit more detail later. Finally, December 2021, and volume 64, so they've been going for years. Look at this, 1 to 6 gigahertz, 600 watt solid state linear power amplifier. Well, that could be quite interesting for microwave people. And that's what it looks like. Can run the legal limit here in Australia, 400 watts. So that's the guys you get it from. Wouldn't be cheap though. So that's it. That's our look at Microwave Journal. So thanks to them for sending me all this, and find out more at mwjournal.com.